Hello friends, today we will continue with studies on energy methods. So these come in module 4. In module 4, where it is energy methods. So here we will be studying three methods. First is strain energy. Second is unit load method. Third method is Castigliano's theorems. So today we will continue with, or we will start with unit load method. First we will derive the equation for unit load method. So unit load method, application to beam deflection. How to find deflection of a beam at any given required point. So consider a beam element as shown. Let system of forces are acting on the beam. Consider an elemental area at distance y from CG axis. So let us draw a typical beam element. Let this be the beam. Supports. Now for this let me draw the CG axis. So CG axis is somewhere here at the center. Let a system of loads P1, P2, P3, P4 they are acting. Consider an element. Let the forces on that element be P. Let its distance be y from the CG axis. Let the elemental distance be dx. Now this is typical beam subjected to loads. Beam subjected to loads. Now I am going to consider a same beam element, a same beam wherein unit load is acting at the required point. If I want to find deflection at this point, I am going to apply a unit load. So that is why this method is also called as unit load method, or it is also called as virtual load, an imaginary load which you are applying. Let this be the CG axis. Consider an element. Let its distance be y, element of length dx. So these are the forces. So beam element or beam subjected to unit load. Unit load means 1 kilonewton load. Now strain in element is given by E is equal to integration of m by EI into y. So this is pure bending equation. Let small m be the bending moment due to the bending moment due to unit load, that is 1 kilonewton load. So stress is given by stress P dash is equal to m by I into y, pure bending equation. Now from earlier equation we have strain is equal to delta is equal to m by I into y into m by EI into y dv. So same, this m, capital M, is due to given loads, and this is small m. This is small m due to unit load. Bending moment due to unit load, bending moment due to given external loads. So I have deflection delta is equal to integration of 0 to L capital M small m by EI square. So same, I am going to take 0 to A y square dA dx. This dV I am going to divide into dA and x, area into distance, it gives volume. Next I have integration of y square dA is equal to I, moment of inertia. Hence I can write delta is equal to 0 to L capital M small m by EI square into I dx. So this gets cancelled. So I have delta is equal to integration of 0 to L capital M small m by EI dx. This is the only equation for beams. So what this says is, or here capital M is bending moment due to external loads, small m bending moment due to unit load. Just remember the equation, delta is equal to 0 to L capital M into small m divided by EI into dx. So this is the strain energy equation, this is the unit load equation for beam deflection. So unit load method is also called as, it is also known as virtual load. You are applying an imaginary or a virtual load. So this is the equation which you have to remember. Thank you.